Welcome viewers. In this video we are going to learn about containerization process 2. So basically there is a similar kind of video in my channel where I have explained you containerization process 1. So in this video what we are basically going to do is that first we are going to create a flask application. Then we shall move that flask application into a Docker container, or in other words we are trying to containerize a flask application. In my previous video, first we had built a container. Now inside that container we wrote a Python code, and then we tried to save that container, convert it into an image, and then we transferred that image from one folder to another, tried to mimic the deployment part of it. But in this tutorial, first we shall write a flask application. That will be a very small basic flask application. Then we will try to containerize it. The diagram which you are seeing in my screen, I think you guys have been familiar with my images. So this is my home lab diagram. So basically what we are going to do is that the large circle that you are seeing, the large red circle, it is my remote machine. It's an actual remote machine. It has Ubuntu OS inside it, and on top of that I have installed Docker engine on Ubuntu OS, and that Ubuntu OS, or you can say that Ubuntu machine, has IP address 201. Inside that we shall build one flask application. Once that flask application is up and running, then we shall convert that flask application into a Docker container. I will explain you this image in more details. So first we shall write a flask application. So for that I shall open VS Code. I have created one folder. If you can see it, just a minute, let me minimize my screen. Yeah, this is Visual Studio Code. So first we shall create one virtual environment. So as you know, the folder name is YT Flask App Containerization. So first I shall get into that folder, YT Flask Containerization. Okay, it is empty now. Then I will create an environment. So to create one virtual environment in Python, we shall use python -m venv. Then I will give it name envx. You can give any name. So our virtual environment has been created. You can check it. You can write it ls. You will see there is a folder called envx. Now if you want to activate this environment, for that in Mac and in Linux you will use source, then envx, the virtual environment name, then go inside bin folder, then activate. So your environment has been activated. Now if you want to know what are the packages that are there inside that environment, you can use pip list. Okay, so I have pip and setup tools. So as we are going to see how we can containerize a Flask app, so we need to install Flask. So pip install Flask got installed. If you want to check again, you want to write pip list. So you can see Flask and its supporting libraries has been installed. There is one more similar command, that is pip freeze. So that also shows what are the packages that are installed in that specific environment, means in the activated environment. Now what is the difference is that basically it has the version number with that equal to sign, so that when you will make a requirement.txt, that will be quite visible. Okay, that is the most important difference between pip list and pip freeze. If you know any other difference, please let me know in the comment section below. So once our environment is ready, we shall make one Flask app. That will be a very simple one. So I will create one more file inside this folder. Go there and create one folder, that is I will name it main.py. And remember, these files and these environments, what I am creating, this is basically inside. Wait a minute, let me share my screen. Whatever we are writing inside PC with Ubuntu OS. Till now we haven't created any container. So this dark blue rectangle is not created now. We haven't created any Flask container. We are writing the code inside the hard drive of Ubuntu OS. Okay, let's start writing the Flask code. Let me open my VS Code. Where it is? VS Code. Yeah. Okay. So come here. This is not required at all. Come in this place. Okay. So open VS Code. Yes. Coming back to the Flask app. First we shall import Flask. So from Flask import Flask. Then we will have app, we'll have one object of it. So Flask will have __ name __. Then we will define two routes, app route. One is simple backslash and another one is app.root. Then you go inside and type home. Now why I shall giving two routes? That is simple because for our convenience, if we give only the IP address, then also it will show our page, and if we write /home, then also it will show our home page. So once two routes has been defined, then we shall define the function. It will be def home, and inside it will have a basic function, that is I am calling from Flask home page. Okay. So once this is ready, then we will write that boilerplate. So that goes something like this: name equal to main. Then we'll write app.run Inside that we will have couple of arguments, or you can say the parameters. First will be the host. We will give, I will show you 0.0.0.0. So why we are giving 0.0.0.0? Because we want our web page should be accessed by all the computers or all the machines under a same network. Then we will have port port equal to 5000. Then I can have a debug equal to true. Okay, so this is our Flask app, very simple Flask app. So once this is ready, we can test it. I will show you the diagram once more. Let me show the web page. So where is my web page? Yes, yeah. So this is the diagram that you are having. Now we have wrote our Flask application inside Ubuntu OS hard drive. Now we want to access the Flask application from the Mac OS, that is 192.168.1 something. That is my IP address. So I want to access the Flask application that is residing under Ubuntu OS under this machine 201 from my Mac OS. Okay, so for that, if we try to run our application now, you will see there will be a problem. So let's run it. So as planned, it is running, and if we copy this IP address, open Chrome, paste it over here, it's not running. One more way to check is that you can use Postman and you can paste that same IP address over here, and you will see it is not running. Sorry, it is running, but it is unable to access. Now what might have been the issue? The issue is the firewall. Firewall is blocking the packets. So you need to configure the firewall in such a way that it should access the packets. Means my Mac OS, my laptop should access the packets of the Flask application or the machine who have the Flask application. So we need to configure it basically. So I have opened one terminal. This is the terminal of my Ubuntu machine. You have to configure UFW in such a way that it should allow our packets. Okay, now first and foremost, you need to go to the configuration files of UFW. So that resides /etc UFW /system conf. Okay, so there you have to paste these lines of code. Even if you don't do, then also it will work, but it is safer to keep it. I think these 4 lines, all these codes are present in my website, that is thesiliconboard.com. I will give the link in the description section below. You can go and so uncomment these lines. These lines are uncommented. Now you can check my UFW. How does it look? UFW status. So currently I have configured my UFW that is only to make SSH connections. So port 2022 is SSH and port 445 is for something else. Currently I don't remember. Currently I have to configure our UFW so that our Flask application should be visible to other machines. Now to do that, we will configure. So that command is UFW allow from 192.168.1.0/24. Now what basically we are writing is that there is a network whose IP address is 192.168.1.0. So this IP address points to my router. /24 means first 255 IPs are open to my machines. So any machines under this IP address, under this router, will get access of the web page. Now next is 2, where it is pointing to, that is 192.168.1.201. Port is 5000 and proto is TCP. So I will explain you this command once more. UFW allow from, it is allowing from all the machines under that specific network to what is the IP address of my server, that is 192.168.1.201, at which port our Flask app is running, that is at port 5000, and what is the protocol we are following, that is TCP. So rule is added. Now if you check the status over here, so a new rule has been added. Okay, now remember again, all these rules are done on my Ubuntu machine. It is not in the Docker. Get into one layer deep after some time. Okay, now if you come over in the Postman, if you try again, then also it will not show, because we haven't reloaded the UFW. So UFW reload, so it will reload whatever. It is a kind of a refresh of Windows. So now if you will check again, UFW status, okay, everything is there. So you remember what is the IP address we have given. Now come to the Postman, and now if you hit, you can see I am calling from the Flask homepage. Okay, so layer 1 task is done. So we are accessing our Flask from a remote machine. Now inside that remote machine, we will have a Docker container. So we will extract the Flask application from the Docker container, and we will try to access from our laptop. So now I will have some modifications over here. So this is fine. So I am calling from Flask homepage. Okay, I will write it flask homepage, flask, I am calling from flask homepage, and now I am in Docker container. Now we are going to containerize it. Okay, so save it. So once it is saved, we'll create a Docker file. Now first go inside our folder, that is YT Docker containerization. Now we'll create a Docker file. So come here, and this is our folder. Where is that folder? I will write flask Docker file. Knowingly, I am changing its name to flask Docker file. I would have given flask only Docker file because of some extra settings that you guys need to know, that if we have a different file name, a different Docker file name, then what need to be done. So to make that life a bit easy, so I am writing some other name, a similar name. So this is a Docker file. Now once we are I think I have created a folder, so let's delete it, delete permanently. Yes, delete it. Come over here, where is it? Yeah, come over here, new file, flask Docker file. So file F capital D capital. So this is our Docker file. Now inside that Docker file, we said write some instructions so that Docker engine can create one image from the commands that we'll write inside the Docker file, and we will have an image that will have our Flask web page as well as Python, as well as some bare minimum OS level file system. First is from, one important thing is left, that we need to create one requirement.txt. So you can check in my folder, we have only two items. So you can, I will show you once more, ls-l. So we are having 3 items. Now I shall create requirement.txt. So that is pip freeze, one symbol greater than symbol, then QUI, be careful about your spellings, ments.txt, requirements.txt. Okay, ls, yes, there is a requirement.txt. If you want to check, use cat command and you will see all the, I think there is a problem. We need to delete requirement.txt rm requirement.txt, because I haven't activated my virtual environment. That's why it has taken all the libraries that are present in my by default Python that is there in the Ubuntu OS. So I need to remove it. So once this is removed, source envx, I will go to bin, inside bin, activated. I will create the requirement.txt. So pip freeze requirements.txt cat requirement.txt. There you go. So we have only those libraries that are there inside our environment X. Okay, now we will create one Docker file. So because now why we want a Docker file over here, because we want to create one image. That image will host the Flask application. So we will call from Python 3.9 slimbuster Python 3.9 slimbuster. I will use 3.10. Then I will have work dir /app. So our working directory is set. Now we will copy the requirements.txt to current folder. Now once this is done, I will go and I will then we will use a run command, run pip install no catch dir -r, then requirements.txt. Basically pip, when this command will get executed, it will not hold any cache, means it will not have any memory where unwanted stuff will get stored. So it will clean up, it will flush out all the stuff that will be there in the RAM. Come to the next line. Now we'll copy dot. Okay, basically we are copying all the contents from the application code to the container. So present directory to the containers directory. Now we will expose our port, that is port 5000. Once that is exposed, then we will write the command, that is cmd. We will have a pair of square brackets. Then we will have flask command, flask, comma, go inside. I think we will have only one. Then -app, comma, go out again, inverted comma, main. Then we will have run. We will write run. Then -, host, that is equal to 0.0.0.0. Then we will write -port equal to 5000. So basically it is the same command, but we are writing it once more so that we are specifying the port, all other stuff. Now once this is ready, we will create a Docker image. So I will show you my terminal. So if I write a Docker image ls, these are the existing image. So I will, let's delete this my Flask image. So rm docker rmi So this is the list of images that are there in my Docker machine. So now I will move to my VS Code. Now I shall execute docker build command to create one image. So the command is docker build -f. What is my file name? That is flask docker file. Then I will current directory from where it will extract, means where this docker file is being located. Now -t. My image name would be my flask image latest. So this command will create one image from using this file, and the image name is my flask image colon latest is the tag. Okay, let's build it. It will take some time. Okay, we got some error over here. Slimbuster, I think I need to check it. Okay, flask port equal to 3.3. Okay, so now our image is ready. If you want to check, you can go to the terminal. Here you write docker image ls. So you will see we have created one image, that is flask image latest. So this is our image now is ready. So once our image is ready, we have to run this image. So to run this image, as you might have known from my past videos, we can use docker run command. So now docker run -it -d name I will give let's say flask app1 privileged privileged -p. Now this part is important. -p defines the port. So here what I will do, I will give 5001 colon 5000. So the first 5001 is the port of my Ubuntu machine. 5000 colon 5000, the right hand part of it, that is 5000, is the port of the Docker container. So now the Flask app that will going to run, we can talk to that Flask app using port 5000, and it will get mapped with 5001 of my Ubuntu machine. Means if I take that diagram once more to you guys, then you will understand. Let me minimize this screen. Let's minimize the screen. Okay, now port number 5000 of this Flask container will be talking to port number 5001 of my Ubuntu OS. Now you can think about, I have kept UFW over here, is that UFW is kind of a gatekeeper. It checks which data packet will come and which go out of this container. Okay, so this is the work of UFW. Now coming back to our problem. So 5000 port number is of Flask container. 5000 is mapped with 5001 of Ubuntu OS. So that's why you can see I have written over here. Okay, this all codes are there in my website. Just I am reminding you once more. So now move to our web page. Now opening my screen. Yeah. Now here I will name Flask image latest. My Flask image. What is that image name? My Flask image. Copy paste over here, latest. So this is our command. Now let's fire it. It is running to check docker ps-a. So you can see Flask app container is running on port number 5000 and talk to this container from 5001 port. Now if we go to our postman, if I click over here, then technically we should get into the container Flask, but it will not go because again UFW is blocking the traffic. So we have to configure it in such a way that UFW should get the traffics. Okay, so we have to configure the UFW again. So there is a command. Using that we will configure the UFW. So come over here. Now this command is a bit lengthy because we are rerouting the traffics using our hardware Ethernet card. I will have a special dedicated video on UFW. So there I will explain all those commands and how UFW is working, the different commands that are associated with it. So this video is completely how to containerize one Flask app. So I am not getting into the details of UFW. So UFW root allow in on EPENP to S0. So this is my Ethernet card of my Ubuntu machine 192.168.0/24. Again the same story. From where? From any PCs under that network out on Docker 0. So Docker 0 is a virtual network card of Docker to 172.117.0.0/16 port 5000 proto TCP please see. Let me explain you what this command is doing. We are instructing UFW that you need to reroute the packets that are coming to ENP2 from any IP address of this network to which card, that is Docker 0. Now the IP address that is that I have mentioned, that is 172.17.0.0. It is the IP address of this Ethernet, of this virtual Ethernet card. /16 means any machines that is under the Docker environment. Okay. Now here 16 means first two are allocated for the networking domain and the last two are allocated for the domain part of it. Okay. Now port number 5000, as you know, the Flask will run on port number 5000 proto TCP. I will research on this UFW in my upcoming videos. So once this is done, let's trigger it. So rule is added. You can check UFW status. Yes, we have written some rules. We have allowed the network forward. Now if you come here in the postman, again you can see now it is replying you that now I am replying you from the Docker container. This is how you can containerize one Flask application. Okay. Now all the things that I have done, that is already there in my website, so you don't have to write any code. You just copy and paste it. You will understand what I am doing. So this is all about containerization process 2. So let's meet in the next video.